Going through factoring. Well, in order to factor, everything's got to be on the same side. So I got to bring over the 6x. So I got to subtract it over. That gives me x squared minus 6x minus 7 equals 0. Now I'm thinking about two sets of parentheses. What are the factors of 7? They're actually 1 and 7. And they do subtract to give me 6. So I have an x plus and an x minus, one of each sign. I need it to be a negative 6, so the 7 goes with the minus sign. Again, when you don't have a coefficient on the x squared, the bigger factor will go with the sign in the middle. Okay, 7 is the bigger factor of 7 and 1, and so therefore it will go with the minus sign that is on the 6. Do that. Once we put a coefficient on the x squared, then we got to be careful. On number 2, we didn't solve yet. Sorry. X plus 1 equals 0, x minus 7 equals 0. Subtract the 1, x equals negative 1 is one of my solutions, and then x, plus 7, x equals positive 7 is the other solution, okay? So there are my two solutions. Now I go to the other one. Always look at factoring out a greatest common factor. Unfortunately, yes, 4 and 24 have a common factor, but 35 does not. And again, I've seen on some of your all's work, some of you actually would divide the 4 into the 4 of the 24. You got to also divide 35 by 4. You can't just pick and choose who's get divided. It's the properties of equality. So if you're going to divide through, everybody on that entire problem gets divided by that same number, okay? So this case, I can go straight to my parentheses. And again, my A is 4, so that's 1 and 4, 2 and 2. My C is 24, so that's 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, here's the one thing I want to keep in mind. I got to add to get an odd number. That means when I get done multiplying, I need an odd and an even. I can't have two evens. So in a way, I know 2 and 2 can't be used. Because when if I'm using 2 and 2, yes, they make 4, but they make everything even, and two even numbers had to be even. So I know it's got to be 1 and 4 is what I know it has to be. Now I just got to play with the other options here. Again, I'm going to use logic. It's not going to be 2 and 12, and it's not going to be 4 and 6, because those are both even numbers. Again, I would have two even numbers after doing products. So I know I'm going to have to do the 3 and the 8. Because 1 and 24 is just too huge. And I got to make sure I do odd times odd and even times even. That way I stay with getting at least one odd number. And then when I add together, I get my odd in the middle, my plus 35. So we can go ahead and put in an x plus, an x plus. Again, since we're adding and they both have same signs, we really could just go ahead and throw in the 3 and the 8 after a plus sign, because they got to make the 24 at the end. Now I got to be careful where I put the 4 and the 1. I want to multiply 4 times 8, so 4 has got to go in front of the x with the 3. That forces a 1 in front of the other x. Now I split up using the zero product property. 4x plus 3 equals 0. X plus 8 equals 0. And then I solve for my two solutions, which are my x-intercepts, which are my zeros. Trying to use all those vocab words. So there's the first one. Second one, x is equal to negative 8. And again, I know they're ordered pairs, so I know I can go negative 3/4, comma 0, and then negative 8, comma 0. Yes, when we're doing the paper stuff, we can do the listing method and stuff. That's just when it's on the line, we can't really use that as an option. So, square root method. We can only use the square root method when missing the bx term. The bx term. We have to be missing that term in order to use the square root method. The idea with the square root method is to get everything away from the x squared. Isolate the x squared. So that means I need to move the 2 first. And I get 10x squared equals 280. I then divide both sides by 10. I've now isolated the square root. Now I get to take the square root of both sides. Now 28 is not a perfect square. That's okay. We're big kids. Now here's where I ding quite a few of you. Some of you kept forgetting to put the plus and minus, and so when you wrote your answer, you had one answer. There should be two answers here. You all had the positive answer. You also need to include the negative. Get in a habit of writing that plus or minus symbol at that stage there. So now the square root and square cancel. I get x equals plus or minus square root of 28. We learned how to simplify. So that's where we split that up into a perfect square factor times its partner. So biggest perfect square factor of 28 is 4. It's the only perfect square factor besides 1. And then now I can split that up as x equals plus or minus square root of 4 times square root of 7. So x is equal to plus or minus 2 root 2. Oh, sorry, 2 root 7. My bad. Whee. And that means there's my answer. Two answers. I got a positive version and a negative version. When you're using the square root method, the vertex will always be on the y-axis of your parabola when you go to graph it. Okay? So on the next one, I'm going to subtract the 50. I get 2x squared equals negative 216. Divide both sides by 2. X squared is equal to negative 108. And then this is where we get ready to stop. When I square root both sides, some of you didn't stop. We cannot take, when I get to this stage right here, I have to stop and say there is no solution because cannot take square root of negative number. And again, as I've seen some of your all work, some of you just keep going with the simplifying. You can't. Yes, there is a perfect square factor of 108. It's 36. 36 times 3 is 108. But we can't go any further. So we got to stop and say no solution. Some of you, as I've been grading your mastery checks, kept going and going. All right, we're not allowed to. But again, if you drop that negative off the 108, then we get to keep simplifying. So don't have to do completing the square. Quadratic formula. Again, this is, you're going to have it memorized for Friday. So x equals negative b plus or minus square root b squared minus 4ac, all of that over 2a. And again, as I'm in the middle of grading this one right now. When I saw some of you do this one, a couple of you only wrote the fraction line underneath the b squared minus 4ac. It's underneath the whole thing. So some of you reduced that part and left the first number out there bigger than it should be. It's the whole top over the 2a. All right? So everybody's got to be on the same side in order to identify whose A, B, and C are. So my A is 5. My B is 4. My C is 1. Now we plug it in. X equals negative 5 plus or minus square root 5 squared minus 4. It's a minus in the middle there. Times 5. Or sorry. Dang, Mr. Stevens. Where's your brain going? You guys didn't even get me yet on that one, did you? Yeah, it's supposed to be stinking 4. My apologies on that one. That was really bad. All right, should be negative 4 plus or minus 4 squared minus 4 times 5 times 1. My apologies. That was really bad. 2 times 5. All right. And then now I just start simplifying. X equals negative 4 plus or minus square root 16 minus 20 over 10. X equals negative 4 plus or minus square root of negative 4 over 10. And then we stop and we say no solution. Because of that negative right there. Okay? Because of that number being on the inside is negative, that's why I got to stop and say no solution. Did I reduce the 4 and the 10? No. All right, some of you were reducing those two things. You can only reduce if all the outside numbers have a common factor. I know it's negative 4 out front, negative 4 on the inside, and 10 down the bottom. They're all 3 even, but you don't reduce with what's inside here, ever. I saw a couple people do that. Remember, I gave you that tip before. We never reduce inside here with the factors of these guys. Okay? So that's as far as we go on that one. Next one, got to bring the 5 back across. I get negative 2x squared plus 2x minus 5 equals 0. Now I identify my A, B's, and C's. Question?
So do you like to reduce
The only time you're allowed to reduce is if it looks like this. Now I can divide all 3 outside numbers by 5. But if that 5's not there, nobody reduces. Okay? So, all right, my A is negative 2, my B is positive 2, and my C is negative 5. So x equals negative 2 plus or minus square root 2 squared minus 4 times a negative 2 times a negative 5 all over 2 times negative 2. All right. X equals negative 2 plus or minus square root 4. Now, a negative times a negative times a negative is a negative. 4 times 2 is 8 times 5 is 40. That's over a negative 4. This is where I should be thinking, okay, I have a negative on the inside. I get to stop and say no solution. Just a coincidence, the person that created this stuff here just had back-to-back no solutions. Not always going to happen. All right, they just chose 2 problems to put in this part of the thing, and it just worked out to be no solution both times. Yes, Landon. Do what? Don't even need to. You don't have to. And because since we can't simplify any further, you don't have to. If you're allowed to, yeah, you would actually cancel out those 2 negatives. Because technically we're not allowed to leave in the bottom of a fraction, we're not allowed to leave a negative sign. We're not allowed to leave a decimal in any part of a fraction. We're technically not allowed to leave what's called a square root in the bottom of a fraction, or a cube root in the bottom of a fraction. And then we have to simplify it. It's the what? It means like you have the radical with a little 3 and the little part there. I get to teach you guys that stuff in the next couple chapters. And so in those chapters, that's when I teach you how to get it. When there is a square root in the bottom, how do you get it out of there? I get to teach you that process. It's called rationalizing the denominator. So, all right, now, choosing the best method. Which one should you choose? Now, looking at these examples real quickly, 11 we should be doing by what method? Does it have the bx term? No. So we should be doing the square root method on this one. Now, on the first one, number 9, that's off the table because I got a 3x in there. So my options for this one are either factor or quadratic formula. Those are my options. Okay? I'm going to first go through the fact of trying to factor because I like to factor first. Okay, that's what I like to do. So I'm going to keep my 2x squared positive. So I'm going to bring the 3x and the 10 over to the other side. This gives me 2x squared minus 3x minus 10 equals 0. And then I'm going to get it set up, and I'm going to go through and say, is there a way to do it? x plus, x minus. Let's see, that'd be factors of 2 are 1 and 2. Factors of 10 are 1 and 10, and 2 and 5. Is there a way to multiply 1 and 2 with 2 and 5 and subtract and get 3? No. Because 2 times 2 is 4, and 5 times 1 is 5, and 5 minus 4 is 1. Okay, so I cannot factor. I'm now forced to do the quadratic formula. A is equal to 2, B is equal to negative 3, C is equal to negative 10. Now, if you went straight S,
So what about negative 5?
no, it doesn't matter that 5 minus 2 is 3. We got to involve this 2 over here too. I know 5 minus 2 is 3, but we got to use this as well. So when we multiply, there's no way to arrange. I'll show you on that one. Like if I know I have to use for the A 1 and 2. For C, if I go 5 and 2, that gives me 5 and 4 subtracted as 1. If I reverse and say 1 and 2 and then switch it to be 2 and 5, that is 2 and that is 10 subtracted is a negative 8. Okay? So there's no way to get 3 when all 4 of those numbers have to be used in the process. Okay? If the 2 wasn't in front of the x squared, sure, we could have gone out and factored it. All right? Did that get your question 2 in the back? Okay. All right, so I'm forced to do the quadratic, so I'm going to erase some of that junk there. And then now we'll go quadratic formula. So x equals negative 3 plus or minus square root negative 3 squared minus 4 times 2 times minus 10 all over 2 times 2. And I'm going to pause because this is where I've noticed some people make mistakes, and I want you to pay attention to what I have up there on the screen. Notice I showed the double negative. It was a negative 3 for B, and I showed the negative from the formula and what that B was. Some of you are dropping off the double negative and just put minus 3, which means you're going to be totally wrong when it comes down to the end. All right, you've got to show the double negative so they cancel and make it a positive 3. Here's the second thing. And this requires you to look at my finger on the screen. This is where I'm pointing right here. When you get done squaring, that should always be a positive number. Some of you, as I look at your work, I see you having this as negative 9 as you write it down. That's because you're going negative 3, hitting the squared button in the calculator, and it gives you negative 9. Okay? Go ahead and do it. I mean, I'll show you on the screen. Because I talked about it, but if I grab a calculator and I get out here to the TI calculator, and I go in here and I say, come on, that's quizzes. Come on, calculator. If I go in here and I say, give me, that's like rude, give me, get out of there. Negative 3 quantity squared, because that's what some of you are doing, and you hit enter, it's going to give you negative 9. And the reason is because it sees negative 3 squared as negative 1 times 3 squared. So negative 1 times 9, which is negative 9. That's what it sees. It sees order of operations. The negative is not encompassed in the squared part. And that's why it gives you the negative 9. So that's why you got to be careful. And again, I always use parentheses when I substitute in for a letter. That keeps that whole part being squared. And so, I would get in the habit of doing parenthesis, negative 3 there, and then squaring it. That's what I get in the habit of doing. Or you got to think about it, it's negative 3 times negative 3. And 2 negatives make a positive. Okay? All right, simplifying here. X equal, come on, catch up there, internet. X equals plus or minus. Now, it's positive 3 because negative makes positive. That's 9. Negative times a negative is a positive, and then 8 times 10 is 80. And then that's all over 4. And then I have x equals 3 plus or minus the square root of 89 over 4. Then I think about, are there any factors of 89? And if I'm not mistaken, it's prime. Okay. So I'm done. That tells me I have 2 answers. 3 plus the square root of 89 over 4, and 3 minus the square root of 89 over 4. Those are my two answers, each of them with a comma 0. Now, what would that mean? They're really crazy decimal answers. They're not nice decimals. They're long decimals that don't stop. They're irrational decimals. Okay, that's what that means. That's where on Desmos, if we graph the original problem and put our finger on the dot where it crossed the x-axis, we would see a real long decimal there is what we'd end up seeing. All right. Number 10. Again, we have all three. Well, we have two of them that have x's. So let's bring the 2x over. So we get x squared plus 8x equals 0. We could do factoring, or we could do quadratic formula. When it's two terms and they have a comment like that, when they're missing the c, I'd factor. Bring out the x, the greatest common factor. X equals 0, x plus 8 equals 0. Only have to move the 1 over here. So my two answers are 0, 0, and negative 8, 0. Those are my two intercepts. Quadratic formula, we would have gotten the same answers. It just took a while, is what it would do. It would take a little while. Okay. All right, we already set ourselves up for 11 square root method. So add the 39. 4x squared equals 49. Now, some of you are trying to do the square root at this stage. Wait until you get the number off the x squared. All right? You can do it, but you got to be so careful. Okay? Best thing to do is isolate the x squared. So divide both sides by 4. I get x squared equals 49/4. I know it's a fraction. Don't turn it into a decimal. Now I take the square root of both sides. Put the plus or minus symbol in front of the fraction 1. Square root and square cancel. I get x equals plus or minus. Technically, it's square root of 49 over the square root of 4. What's the square root of 49? 7. What's the square root of 4? 7/2. Okay. That was actually, at that final part, that was what one of you guys had on your entrance ticket as a problem. It worked out to be 7/2 and negative 7/2 and stuff, and what it ended up working at. I don't know if it was the same original starting, but it at least worked out to be that same thing with the 49 and the 4. All right, next one. It's got all three things, so I'm thinking quadratic formula. I'm thinking factoring. That's what I'm thinking. Those are my two options. Let's just bring the 7 across. And when I bring the 7 across, my brain is already thinking. I'm thinking, hey, 1, I don't like a negative x squared out front. But then I think to myself, it's okay because there's no factors of 7 that subtract to give me 2. 7 minus 1 is 6. So it's okay that I don't have that negative there. So we're going to go quadratic formula. Now, as I point out, another tip. When I go to put this into the quadratic formula, am I putting the letter x in there at all? No. That's what I saw 4 or 5 of you do. I'm not sure anywhere in my notes where I have the x inside the quadratic formula. Well, all we're doing is putting the numbers, the coefficients. That's all that we're sticking in there. No variables go inside there. You're just making it a lot more yucky to look at. And then that's why I see a lot of question marks on next to it, because like you don't know where to go from there. Don't put the letters in there. It's just for the numbers. It's an exclusive club. Only the numbers get to go in there. All right. X equals negative 2 plus or minus square root 4. A negative times a negative times a negative is a negative. 28 all over a negative 2. I should already be thinking what I'm going to as an answer. It does not matter that they all have negatives. It's no solution. The square root part trumps the whole thing. You cannot reduce inside of a square root in any way. So even though there's negatives and you're thinking, hey, I can cancel out a negative, can't do it. Okay, nothing ever gets reduced out of a square root like that. Okay, that's where you got to stop yourself. Because it's so easy to see two negatives, we know they make a positive. Because we learned that back in 7th grade. When we learned energy. Got to hold back. Okay, can't do any of that kind of stuff inside the square root symbol. Okay, yeah, the negative on both 2's cancel. We can do that. I can't divide the 2's, but I could divide both 2's by a -1. But I cannot do anything with that -24. Okay, it's got to stay at -24, and that leads me to no solution. At the end of EOC, I'll teach you what do we do a little bit more with that. It's called imaginary numbers, and you need that for pre-cal or college algebra. So I have to show you that stuff. How many of you are signing up for pre-cal next year, out of curiosity? All right. How many of you are signing up for dual algebra? Okay. So that's why.
This is Stephen.
Yes, ma'am.
Hi, can I have Jonathan Bernard for early dismissal at the annex office?
Of course you can.
Thank you.
You're welcome. I mean, if I said no, would she really, I still got to, so. But that's why we got to hit stuff after, because some of you are taking those. Again, I teach dual algebra in the fall. It'll be in the fall, 4th block, guaranteed. And so you need to know it for it, okay? So we got to be careful. Now we get into the harder stuff. This is what, like you guys saw on your entrance ticket yesterday with the word problem. You only had one equation in your word problem. So here, as we look at this, a lot of times quadratic functions as we get paired with objects being kicked, being dropped, and for whatever their height is as time goes by. And if you plot the height of the object as time goes by, it actually mirrors a parabolic shape, an upside down parabola, okay, is what it mirrors. So that's why we see a lot of these kind of pop up as word problems inside of this unit and doing things. Even dropping like if I was standing up on top of the edge of on the side of the cliff, and I was up here on the side of the cliff, and I took a ball and I just dropped it. If I plotted its height as time went by, 1 second, 2 seconds, 3 seconds, what was its height? It would actually be a parabolic curve, is what it would resemble as we did. Because there's like letters in the teacher's workroom that say, "Don't step up on letters, don't stand on the desk." So I can't plead ignorance for that stuff. So. All right, an astronaut on the moon throws a baseball upwards at an initial velocity of 10 meters per second, letting go of the ball 2 meters above the ground. The equation of the baseball pathway can be modeled by this. All right, so let me give you some information here. In this situation, as we have our h of t, negative 0.8 t squared plus 10t plus 2. Let me give you some information that you need to store inside your mind. And some of you may know this. The last number we know is our y-intercept, but it's also our initial height. It's our starting point. They said they threw the ball in the air and released it 2 meters above the ground, 6 feet off the ground, roughly. Okay? So that's what that's saying here. 2 meters off the ground is when the ball was physically released. So that's my y-intercept, and also known as my initial height, as I finish out that word here. The constant at the end is always the y-intercept and the initial height. Now second, the 10, they gave it away up here. Initial velocity. So that's like the wind back and then launching your arm forward as you're getting ready to release. That's what that process is. It's like as I'm getting ready to throw it and release it, it's got a force of this 10 meters per second. is what it has as a force. Okay. Now, since we're throwing it up into the air, it's positive. Sometimes we see problems where they say that, a sub is diving into the ocean, diving down at a speed of this. Well, if you're diving, that's negative action. Okay, so as we look at other problems, kind of keep that in mind. This is being launched up in the air, that's why it's a positive initial velocity. If this was going down, then it would be a negative action. Okay, question?
So it's how do you do it?
Yeah. It's the rate of change, yes. Now, the number out front here on the t squared, this is gravity. In these kind of problems, that number is always going to be, since we're dealing with meters, they have it set up that way. It's usually either, of course, that's gravity on the moon, is what that is. So that's gravity on the moon. So like over here on Earth, this is the typical number we see for the gravity on Earth in the metric system. Sometimes we saw it on the entrance ticket yesterday. There was a negative 16 t squared. Anybody remember seeing that? A negative 16 out front? That's what it is when we're doing feet. It's always, when you're dealing with feet, the U.S. customary units, because we got to be different in the United States. When we're dealing with feet, gravity is always a negative 16. If you see an 8.9, that means you're dealing with the metric system in your problem, is what that means. Now, that's just extra food for thought. Anybody think about taking physics next year? Okay. All right, so the same experiment is done on Earth. They tell us what the model of the equation was there as well. Same speed, just different gravity. That's the only thing different. Still released it off the ground, 2 feet in the air. They let go of the ball, same initial velocity. How much higher would the ball stay in the air on the moon? How much longer? How much longer? Okay. Would the ball stay in the moon? All right. So if we think about our pathway here, we know the y-intercept is 2. It got launched up, then eventually comes back down, and then it touches the what? Touches the ground, right? All right, so this is ground here. So the amount of time here, this is my time is on my horizontal axis, so we know that's the ground. This is how long from x is equal to 0 to x is equal to this spot here. That's how long it was in the air. Okay? So from when it started to when it hits the ground, that's how long it was in the air. They're asking us how much longer would the ball on the moon stay in the air more than on Earth. Okay? We know things on the moon don't come down quickly because of the gravity. So what I need to do is I need to figure out, let's let this be the moon. And then on this one, I got to figure out, same start, it goes up. It just came down a little bit quicker. Okay? Because again, we're gonna land on the ground quicker with on Earth. So I need to find out, well, what is this x-intercept on Earth? And I also need to find the x-intercept on the moon. And then compare to see how much longer. Okay? So again, now that we know we're finding x-intercepts, I'm doing quadratic formula, I'm factoring. Those are my choices because I have a 10t. So I got to do those. Now we can also graph. All right, we can also graph. Big ideas would be doing this one with the quadratic formula is what they're going to be doing. So let's do first the moon with quadratic formula. So x equals negative 10 plus or minus square root 10 squared minus 4 times negative 0.8 times 2 all over 2 times negative 0.8. Ooh, this is yucky. X equals negative 10 plus or minus square root of 100. Negative times a negative is a positive, so plus 6.4. Again, 4 times 2 is 8. 8 times 8 is 64, so it should be 6.4. On the bottom, we get negative 1.6. And so now we're going to be a calculator activity. I'm not going to bother trying to simplify 106.4 and figure out its perfect square factors. I'm not that much of a nerd. All right. So I got 2 answers. I got to do negative 10 plus that square root. And I got to do it again with the minus between it. So this is when I got to go to a calculator. Oops, Mr. Stevens said minus and he put a plus. Doofus. Minus, there we go. All right, split screen. Let's go calculator. I'm going to do alpha y equals to give me a fraction. Alpha y equals gives me a fraction. Hit enter. And then I'm going to start typing in negative 10 plus second square root 106.4. Arrow down to the bottom and put a negative 1.6. I'm going to use that to my advantage. I'm not going to take the square root of 106.4 and then retype stuff in. Let's just create that fraction. I hit enter, and the one with the plus sign is a negative point, come on, pen, negative 0.1969 seconds. And then I now have to do the other one. And this is where the calculator comes in handy. We don't have to retype all that back in. If you press second and the enter button, it takes the last formula you did and puts it on the screen. Now all we have to do is arrow back and then change that plus sign to a minus sign. Is all I got to go through and do. Save myself a heck of a lot of time. And then hit enter. And I get 12.6989. Now, do I need to worry about both of those answers in the context of this problem? No. Why? Why is it not possible? It's negative time, which means going back in time. So the negative 1.9 or negative 0.196, I don't need because we can't go back in time. Okay, so I only need to worry about this as being my moon thing. It was in the air for 12.6 seconds, 12.7 seconds is how long it was in the air. All right, now I got to do it for the Earth. Same situation. So now we go over here. So we're going to use this one. That's the moon. That's the moon time, how long it was in the air. Now I got to do the Earth. So the Earth equation. Let's see. It was h of t equals negative 4.9 t squared plus 10 plus 2. And so my a is negative 4.9. My my b is equal to 10, and my c is equal to 2. Now, we're going to get smarter here. The only thing that changed was the a value. So really, in my formula, we have still negative 10 plus or minus square root of 10 squared minus 4, now times 4, negative 4.9 times 2. And that's all over 2 times negative 4.9. All right, so with that in mind, negative 10 plus or minus square root of 100, and then we're going to do it's a positive, so plus 8 times 49. It'd be 2 carry the 7, 39.2. Over on the bottom would be negative 9.8. I did multiply those 3 numbers together, right? Okay, good. I do make goofy mistakes, but usually I'm pretty accurate on my multiplication. All right, now I'm ready to type it into the calculator. So I'm going to go alpha y equals, give me a fraction, negative 10 plus square root 139.2, arrow down to the bottom, negative 9.8, Hit enter. So the positive one, the one with the plus sign, negative 10 plus square root of 139.2 over negative 9.8. That worked out to be a negative 0.1835. Again, we can ignore it because that's back in time. Okay, we don't need that one. So we need the one with the minus. So I need to go back and do second enter. Arrow back, change the sign before the square root to be a subtraction sign. Hit enter. And I get 2.2243 seconds. Okay, that's the one with the minus signs. 10 minus square root of 39.2 over negative 9.8. All right, so now they ask how much longer. How much longer means I need to do what with the 2 times? Subtract them. So now how much longer? I got to do 12.6989 minus 2.22, was that a 4.3? Yeah, 4.3. And then we get 6.474, and then that'd be 10. So an extra 10 seconds, 10 and a half seconds basically almost. Okay. Make sure you pay attention to the decimal places when they tell you to do stuff too. Okay. So it stayed in the air an extra 10.47 seconds. Just depends on what place value they ask you to round to. If they ask you to round to the 10th, 10 and a half seconds. Okay. Again, word problems are long. Word problems that involve 2 quadratic functions are super long when you're trying to compare the 2. Okay? 1 is not bad. Now, the one thing they did not ask us yet, what was the maximum height on the moon? What was the maximum height on the earth that the balls went to? Maximum height is associated with what part of the parabola? The vertex. And so when I'm trying to find the vertex, what should I use? What formula?
Negative b over 4.
Thank you, doing all that stuff. It could be the negative b over 2a. Negative b over 2a. Yeah, there's a lot of letters and stuff, but negative b over 2a. Get that. Remember, that negative b over 2a is the time. That's the time that it hit its max height. To find the height, you got to put that answer back in to figure out what the y value is. Max height is the y value. Okay, so when you just do negative b over 2a, all you found is what time it took that it hit its max height. Now we should see, since it's a parabola, we know the Earth one came back down at 2.2 seconds. So being symmetric, somewhere halfway down there between technically the negative 0.1 whatever that is, and the 2.2, that's where it hit its max height. So somewhere around a second, 1 point something seconds. Whereas on the moon, somewhere around 5 to 6 seconds is when it hit its max height, the time. And but again, we would want to find that number and plug it in, and then get what that is. All right. I wanted to get to that application problem for you guys because I know some of you struggled with it. Here we got another one, cannonball. What is it missing? The C. So that means it's starting on the ground. When you're missing the C in these kind of word problems, that means it's starting on the ground. Like some of you had the soccer ball problem yesterday on your mastery check. Where do most of the time a soccer ball starts? On the ground. I mean, I know when sometimes a goalie, takes the ball and clears and they drop kick it, but most of the time the ball's on the ground and stuff. And so that's why when you see soccer problems, there's no C. All right. Usually a baseball, football, basketball, they always have a C involved because the ball is not always on the ground. It's usually somewhere above the ground. Golf, it'd be on the ground. Okay, you're at Green, you got a little T, but they usually write those problems where there's no height and stuff on there. So again, that last number is always your initial height. So now as we look at this problem, find the max height. So we're going to do that negative b over 2a. Negative b over 2a. And then we're going to do f of negative b over 2a. So my a is negative 16. Gravity is negative 16 feet per second squared. And then my b is equal to 128. So again, negative b over 2a. So that's negative 128 over 2 times negative 16. So that is negative 128 over negative 32. And that's equal to 4. So at 4 seconds, once that cannonball was fired, at 4 seconds, it reached its max height at that time. So that's 4 seconds. I want to figure out, well, what is the max height? So what is h of 4? So put 4 in for t. So negative 16 times 4, that's a t. I'm ready to go home. So 4 squared.
Don't worry, you have 10 minutes.
No. It's, the 4 squared plus 128 times 4 equals. All right, so this is negative 16 times 16 plus 4 times 128 is 512. This is negative 256 plus 512, which is equal to 256 feet. This is when the waking up at 3 o'clock in the morning gets you. Find the time it will take for the cannonball to reach the ground. Reaching the ground is pretty much almost always associated with finding the x-intercepts. That's what we need to kind of store in our mind. When we're asking you how much time does it take for something to reach the ground, is from the starting point to when it hits the ground again. That's the x-intercepts, is what we want to try to put into our mind, what I need to find. Okay? So with that in mind, I can factor this one. That's factorable. So I can take out at least a t. Does 16 go into 128 evenly? Yeah, it goes in there 8 times, right? So I can take out a negative 16t. That leaves me a t minus 8 in the parentheses. And then now I use the ZPP. Negative 16t equals 0. T minus 8 equals 0. Divide by negative 16. That gives me time is equal to 0. So that's my starting. That's when I started. And then 8. T is equal to 8 seconds. So it took 8 seconds until it hit the ground. Question? Yes.
Couldn't you have just multiplied the 4 by 2 to get it?
A 4 by 2. 4 by 2. 4 by 2.
So like it's 4 seconds to hit the max height, but then it take the same amount of time to come back down.
Yes, we could, since it was nice, pretty numbers. Yes, at 4 seconds we hit our max height. Yes, just in case it was some ugly decimal, I'd be careful.
Okay.
It's just with the numbers they chose here, it worked out pretty that it did work out that okay. I won't say it will work out always like that. Okay, so that's why I'm saying.
Alright.
Okay, just be careful. Okay, to me it's safer to go through the quadratic formula or the factor to try to make sure you got them. Okay, especially when they're not pretty like that one is. Joey dives off a diving board. Now, I did talk about diving. All right. I did talk about diving, and diving is a negative action, but why is it a plus 15? Yeah, he jumps up. Okay, he jumped up, so he's got to, as he leaves the board, he goes up with 15 feet per second is what his velocity is. Okay, so now they ask us when Joey dives off the diving board, what's his max height? Again, vertex. We're using that. Again, the more you practice using it, the more you're going to remember it. If all you're doing is plugging that in the calculator and finding the vertex by doing that method, it's not going to help you, for the big picture of stuff. Okay? The college algebra kids in here. I get the choice if I want to allow a calculator in my classroom or not. I've had kids go off to college and tell me, stats-wise, Coach, they don't let us use a calculator. Other math classes, Coach, our professor won't let us use a calculator. Okay? So with that in mind, I get the choice of do I want to let it be allowed in my college class or not. Okay? So the graphing isn't always going to help, being able to graph it on the calculator and pick the part. Okay? So we got to know how to do it by hand. Okay? Besides the fact one day we'll probably lose all power and we'll be back to like Stone Age and stuff. So, all right. So with this in mind, negative 15 over 2 times negative 16, which would be negative 15 over negative 32, which is 15 30-seconds. And then, so that's my time. That was pretty quick. That wasn't even a second.
One bus change this afternoon. Bus 662 is going to be 638 today.
All right.
And if you ride bus 662, today it's going to be 638. Thank you.
Now this stinks. Oh, that is just bad. Those are like ugly stuff. So I'm not even going to try to show off doing that stuff. We're going to go straight to the calculator. All right, so calculator, here we go. Get that over there so I can see it. Negative 16, parenthesis, give me a fraction. 15 on top. Oh, that didn't take my 1. 15 over 32. Arrow to the right, close the fraction, square it. Plus 15, parenthesis, alpha y equals, give me a fraction, 15 over 32. Arrow to the right, and then plus 12. Save ourselves some time. That'll be some ugly stuff. All right, and we hit enter. And this tells me 993 over 64. Let's go ahead and divide that. 993 divided by 64. So 15.52 feet. So now, let's think about it. What was his initial starting height? 12 feet. His feet were 12 feet on the ground, on board, was 12 feet off. They're 12-foot board up, okay? He didn't go up that high because his max height was 15 feet. So once he left, he got up 3 feet. So just imagine like from the ground to the desk. That's as high he's got in the air. He just left, came right back up. All right, he wasn't up there long. That's why the time was so fast. It wasn't even a half a second. It was like he was already back down. Okay, so obviously maybe he double bounced himself on the edge of the board or something like that, and he didn't really get a good push to get up, and something happened. He missed time, the jump coming down or something. I don't know. So, all right, your homework's going live here in a few minutes. Same type of stuff. I picked their chapter review that I did before, and it's all these type of things. Tomorrow we'll practice some more. I'll look at what we hadn't gotten through. We'll do a quizzes thing too to kind of go through speed-wise as we do that. And then I'll push that out there when we get done because I'll lead it as a class. I'll push it back out that way. And Sophia, you can do it practicing while you're gone if you want to, okay? And I'll put it up there for like unlimited attempts, like 10 or 12 times. That way it's out there for whenever you want over the next week to do it, okay? All right. I'm gonna